I've been wanting to try this for quite a few days now. So today we're going to put this to the test. We're going to talk a little bit about what a diffusion model actually is. Now, this is a new model. I'm not expecting it to be fantastic at code, but it is named Mercury Coder. So I do want to see how good the code is. We take something that is just fundamental to image generation. For example, one of my most used applications when I first was getting into AI was Stable Diffusion. I was just blown away by what you could generate with this technology. But now, what we have is an LLM that applies diffusion technology to text. And it's really incredible. So, this is built by Inception Labs. And what this is called is Mercury Coder. All right, we're going to start off with one of the hardest problems, which is developing a Python program that simulates traffic flow on a city grid. This is one that you've probably seen if you watch my videos, tested quite a lot. And you will know that very few models actually do a good job at this. So I'm very curious how Mercury Coder is going to perform. Over here on the left, we actually have Mercury Coder. You can get to it chat.inceptionlabs.ai. It's worth trying out. Sign up for an account, and then I turned on the diffusion effect because I want to show you what this actually looks like because it is amazingly cool. Watch this. It might actually be hard to see. That's crazy. Like it iterates over, very similar to the way images start with like rough and kind of filter out. And if you know much about like graphics technology, there's a lot of that like denoising that happens, and that's really what this is doing. So now we have our entire code. Like this is so freaking fast. There's been people in my Discord that have asked me about trying this out, and I've been excited about it, but I just have had so many other things that I've been working on. I cannot quit using this thing. But I'm just like blown away by this technology. I feel like this might be one of the fundamental advancements that we need in LLMs to make our local models even better. Like I am so excited about this. I cannot wait until this trickles into everywhere else. I'm so excited for this. So enough gushing about this amazing technology. Let's see if this can actually run. Only 96 lines of code. I am not confident this is going to be good. But remember, this is a new kind of way to generate code. So I don't expect this to honestly be as good as Claude 3.5 for what these tests are doing. But let's just see if it runs without crashing and then like what we end up getting here. So this is our traffic simulation. We have a very interesting grid layout. I'm not totally sure what's happening. And I think that's pretty much it. So this was very cool, but the code did not turn out very good. So unfortunately, from a coding standard, not super great. So now we're going to move into a little bit easier one to build me a game of Connect 4. And again, if you watch my other videos, I love testing this one because there's so much you can do with this to actually, like, first off, get it functional, but also add additional creativity on it. So let's kick it off and watch how fast this is. Like, this is mind blowing to me. The noise coming in, boom, done. And look at this. We actually got more lines of code this time. We got 273 lines of code. So I'm actually a little bit more optimistic about this one. It's got to be less than like, what is that, 5-10 seconds maybe, if even that, to generate all those tokens. All right, so now let's go ahead and run this game of Connect 4 and please work. I'd be so excited if this works. All right. I think it's going to do it. Now, one of the biggest flaws that a lot of the LLMs that I test has is the piece does not fall to the bottom. It stays at the top or it crashes. So let's take a look at what happens here. No! It got the crash. Oh. All right. So, by far not the strongest coding model. What happens when I tell it something's wrong with this code? Now, it did fail on the one shot. That's okay. Right. Like again, I'm not expecting this to be like Claude 3.5 level, even though sometimes the articles will say that. Here we go. It actually gave me the correct version of the code. Oh my God. I just can't. Could you imagine working with something actually as good as Claude 3.7 or 3.5 or DeepSeek this fast? I just am blown away by it. Absolutely incredible. All right, let's see. All right, so now we have the problem where the piece doesn't fall, but we're not crashing anymore. And the AI is placing a piece. Wow, this is incredibly bugged. So no, this is not doing a good job with the Connect 4 game at all. That's super unfortunate. But we're gonna jump over and test another one just because I want to see. I'll go easier this time. I'm gonna keep going easier and to see kind of the level that I can get it at. So this is a Sudoku board. I want this to write me a Python application that basically lets me solve a Sudoku board using something like a backtracking algorithm. And then I also want to be able to type in numbers. So that'd be the ideal thing. A lot of them work. So most LLMs that I've tested can generally solve this. If it has a problem, what'll happen is a lot of times it gets hung up on the backtracking algorithm and it gets kind of like stuck trying to actually come up with a solution. So we'll see what it ends up doing. We're going to go ahead and kick this off. We created a new chat window just to remove all the context. All right, we're going to go ahead and put this in. Man, this speed is just unbelievable. 92 lines. I mean, this doesn't take much. So now I'm just going to type in some numbers here and then we're going to say solve. Yeah, so now I 1 5. Yeah, it did do this. I mean, I need to verify like it's actually correct, but I'm not seeing any other ones here. Nothing duplicated. It seems to be doing everything, and there's no reset. So yeah, that one actually did really well. Now, this actually might be one of my favorite tests that I do, which is building basically an application that lets me train a neural network to classify handwritten numbers. And then you can actually take it and use that trained neural network to basically go and predict the number when you type it in. I am not expecting this to work. This is a very complex application, but maybe it'll surprise me. But let's take a look here what this does. And again, because it only takes 3 seconds to generate this. Actually, that took longer than I actually expected. That was maybe a good 5 seconds there. Oh man, so we have 63 lines of code. I am not confident about this code at all. That is incredibly low amount of code here. I can't imagine this actually working. Is it gonna work? Gonna load anything? What is it doing exactly? And no, it did not work. We ended up getting an error. I'm just gonna tell it not to load our training data. We want our own and give it the error message and see what it ends up doing. Let me just make sure I'm loading the right thing. Yeah, we're still getting the same error. I'm trying to be a little bit more explicit. This stuff is in the directions that I gave it before, but I'm telling it, no, quit trying to load training data. I want you to create the training data by letting me draw. So this will be the third attempt here, and we'll see what we end up landing with. So we're at 113 lines of code. What are we at here? 72. So it definitely did more. This is getting much more in the realm of I think something that could actually work, to be honest. But again, I'm not very confident this is going to work. So no, now we have an image draw. I'm going to go ahead and tell this the problem. I want it to tell me what's wrong with it. And honestly, the iteration has been good. I was worried about how diffusion would work, in kind of like an iterative fashion, but this is fine. Absolutely fine. So we're going to go ahead and add these things at the top, which is what I expected. So let's just replace this. Take a look, see what the next error is going to be. Sweet. All right. Is this actually going to work now? No, it's failing. It's so close. Let me draw the numbers. Oh man. All right, I'm gonna push this a little bit further just because I want to see what we can do with this. And I'm just having fun with this, and the code generation so dang fast. So cool. And if you stay tuned for the end, I'll talk a little bit about some of the technology behind it. We'll go through some of the stuff they put out. The one thing I don't know is, does it want me to hit train model every time? So what I'm going to tell it now is I don't understand how to train. When I type the number 0, what should I do? I feel like there should be a submit image button and a clear image button so I can keep drawing and creating images. And we're going to see what it comes up with. And cool, it actually is generating already. And we're done. I wonder, with Stable Diffusion, you can kind of set the number of passes. I forget the name for it, actually. The iterations, basically. I wonder if that same thing happens with code, too, where you could actually keep iterating over the code further to actually make it better. Be kind of interesting, to be honest. All right, so we got the buttons that we wanted. So I'm gonna do 0, emit image, no error. All right, so I'm gonna go ahead and just train this. Okay, so I drew all the images. I hope this trains, because otherwise I drew all these images for nothing. Please work. I just drew all these images, and we trained it. Uh, okay, but it didn't switch into like a new mode like I thought it was going to. I wonder if I draw a 2, does it start predicting? No. No. All right. I think I'm gonna end the prompting stuff there. Definitely check this out. Definitely make an account. I made a new account with my gosucoder basically email to be able to do this for the video. But I actually was trying to use it for work a little bit today too. A while, I found this to be from a Python perspective and one-shot coding to not be very good. It did do okay at the Sudoku board, but it doesn't actually have a lot of the creativity like a lot of the other LLMs have, where they'll actually, actually build a fully functional application. I think if you'd be very specific on all the things you wanted, maybe you could get that from it. But I even tried that in some of the follow-ups. I didn't get the things I wanted exactly. So from a coding perspective, it's unfortunately something I can't use yet. From a technology perspective, I have not been this excited about a new AI technology for a long time. All right, so I'm going to transition over a little bit to just talk a little bit about this technology a little bit more. I know I'm pretty excited on it, but take a look at this. So if you look at this little video that was just playing here, you can write a function for an LLM inference. You can see over here on the left side, each token is being generated one by one. And this is what we're used to. And you can see it getting sped up here. And then you look over here on the right side when it comes back around, it's generating all the tokens at one time and then iterating over it. Like, look at that. You see how messy that was? And it's iterating, 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 iterating. Boom. Now, what I'm curious about is like how it knows when to finish. So that's something I actually want to do a little bit digging into. But this is so freaking cool. Like, I am so excited about this. Then we've got a few of these little takeaways. 10 times faster, up to 1,000 tokens per second. We talked a little bit about that. One of the things that I wanted to actually try out is they actually have their generalist models via an API. I want to see what those are and how good they are, to be honest with you. And look at this. The output speed. Mercury Coder Small, Mercury Coder Mini. Can you imagine if we could actually get a Claude 3.5 like level model that performed this fast? I mean, I could see it fundamentally changing like the landscape of AI for forever. Like, what would happen to Claude 3.5? What happened to Claude 3.7? If I could go get a model that is paid for the same price today, and it runs as good as Claude 3.5 Sonnet, and it is that much faster, and it's cheaper for them to run it because it's like less compute, I'm not going to pay for Claude anymore if that ever gets to that point. And the question I have is, how far away is OpenAI from that? How far away is DeepSeek from this kind of technology? How far is Claude away from this technology? Is Inception Labs like the only one that's actually got something like this fundamentally working right now? I will say I don't know about this artificial analysis coding index. I do not feel like the ones that I've tested are actually good at coding. I've tested it beyond even this video, and I've been less than impressed. Impressed with the technology, not impressed with the code. And here's just another chart that I think is very interesting here. You can see the Mercury Coder Mini and the Mercury Coder Small, and then the tokens per second kind of generated for each one. I like the models that it put it up against here, especially for the coding benchmarks, because I think all of these are relatively good, decent coders. They're not the greatest. They're not super strong. I'm curious about this Claude 3.5 one. Being at 31 here, I there's a huge gap in my mind going from like 17 to 31, and you can feel it like using those models. And GPT-4o Mini is the model that I don't actually think is that good at coding. And I've actually just started playing with Deep Coder V2 Lite, so I do think this is actually a pretty good model as well too. And this is another way to look at it here. You know, they show the speed difference. What I'd really want to do is like use a larger one, and I'd want it to actually be, you know, even if it's like 400 tokens per second or 300 tokens per second, I'd want to actually be able to like get the coding quality up. So that's my biggest concern with it right now is like, can they take this technology and make it into something that's usable for me? You know, they're comparing this to like an 8 billion parameter Llama 3 model, which I think is maybe fair, but at the same time, you know, if we're wanting to think of these as like frontier models eventually, you know, we're going to need a Mercury Coder large or whatever they want to call it that maybe takes a little bit longer, but generates tokens twice as fast for half the cost, and they can make a lot of money, and we can actually get a good model that's actually really good at coding. Let me just kind of maybe end with this. So this little demo that they're going to put up here is really cool to show you. Like maybe you're doing something other than code. So we've got Mercury generating a object-oriented programming documentation. Took 6 seconds. We've got ChatGPT and Claude generating the same one. And you can see they're doing it token by token. You're waiting for it. So you ended up with, you know, about 30 seconds to 36 seconds. That speed difference is incredible. I'm so amazed by this new technology that I literally couldn't stop playing with this today, like testing out what I could actually do with it. All right, I'm going to end out with one more while we kind of talk about final thoughts here, because I thought this was cool and I wasn't able to show this with the Python stuff. So they actually do have like artifacts built into this. And this is one of the example prompts that they gave. So I'm assuming they know this one can do well, which is basically build something where particles follow your mouse. But this is done in one shot. It's, you know, a relatively simple application, but it works incredibly well. This is absolutely awesome. All right, I'm going to wrap this up now. I've had a ton of fun playing with this. I will say on the Python side, it's weaker. On HTML, it's pretty decent at it, to be honest with you. When I was giving it like TypeScript and JavaScript files, it did okay on it. When I was doing like some API stuff, I think it did okay on it. But it's not the greatest coder in my experience. I'd be curious what your guys' thoughts are on it. But that's not what's exciting to me about it. You know, of course, I'd love to have a model that's the best coder. What's exciting to me about it is this new technology, taking something that we've known from image generation and turning it into something that's actually generating text at a significant faster speed. And then maybe this will actually trickle its way into local models that we can actually use. And maybe this will actually put pricing pressure on the market because this could be a massive unlock in technology that changes the way we've thought about LLMs from a token per second standpoint to more of an iteration standpoint. I'm going to be watching Inception Labs as they continue this amazing work. And I just want to give kudos to everyone at Inception Labs. This is phenomenal. You know, maybe the code wasn't the best that I've seen, but like this technology literally is like a massive shift in my mind. I did not even anticipate this big of a breakthrough in LLMs for years to come, but it's just very clear to me like we're accelerating at a pace that it's just so hard to predict. Anyway, everybody, I think I'm going to wrap it up there. I appreciate you hanging out till the end if you did. And please let me know if you've tried Mercury Coder, what you think of this technology, and how you think it's going to change the AI space going forward. Let me know your thoughts in the comments below. And if you don't mind hitting that like and subscribe button just to help with the algorithm a little bit, I'm getting so close to 5K subscribers. Peace out, everyone. Until next time.